Hello everyone, how are you? This is Hawar Azmanchi, and this is a tutorial video on that are related to the training course of monitoring and implementing drought mitigation in Iraq. As you know, and all of you have this course plan, we have a bunch of indices that we have to apply in order to reach our goal, or the final goal of this course. First of all, we have to apply NDVI, which is the normalized differences vegetation index, in order to show the vegetation cover in the study area or in any place. So in order to do that, as you know, for calculating NDVI, we need two different bands, which are band 4 and band 5. Of course, if we have Landsat 8, if we have Landsat 7, 4, 5, we have to use band 4 with band 3 instead of band 5 and band 4. So we chose these 2 years, which are 2021 and 2019, just in tutorial purpose, and we use this part of Erbil governorate just for tutorial purpose, but in the class or in the training itself, we're gonna use a lot of years, maybe 10 to 20 years, in order to show the differences between these years. So we have these 2 years, a band 10 for 5 for 2021 and band 10 for 5 for 2019. So in order calculate the NDVI, we have to go to the ARC toolbox right here, or we have this icon in the standard toolbar, or we have to go to the geoprocessing ARC toolbox, all the same. So we open ARC toolbox and go to the spatial analyze tools, and then go to the map algebra, then raster calculator. So we open raster calculator, and we're gonna use float as mentioned in the formula. We will choose band 5. We're gonna start with 2019, so we have float band 5 minus band 4 divided by float band 5 plus band 4, of course, for the same year. And we're gonna name this NDVI 2019. And before starting this process, we have to clip the area according to our study area, because the image itself has a bigger size of this. So we're gonna clip this to be fit in this study area, of course, to make the process quicker and more tidy. So in this purpose, we will choose, or we will go to the environment button right here, and we go to the processing extent, we will choose from default and choose our file right here, same as layer export output right here, and we will go to the raster analysis, and in the mask we're gonna choose the shape file or our study area extent. We'll press OK and click OK. If we off this, here we go, we have the NDVI for 2019 and clip it according to the our study area boundary. So we will repeat this process in order to calculate the NDVI for 2021. We're gonna use the same process, float band 5 minus band 4 divided by float, divided by float, band 5 plus band 4. NDVI 2021, we will use environment to clip the NDVI image, there we go. So we have calculated the NDVI for 2019 and 2021. And as much as here we have in the course itself, we're gonna use the same process for calculating and clipping the area we want. So we're gonna change the color in order to be more clear. As you know, the green values represented the vegetation, and the red or to orange or the orange colors represented the non-vegetation or very sparse vegetation cover. So we're gonna divide the another image of the NDVI, which is from 2021. To the classes which was mentioned in the file that we have. So 0, 0.2, 0.6 and bigger than 0.6. So we have 2019 and 2021. Each of them divided by these classes according to the table which is attached in the file that we have. All of you know that these values doesn't represent the vegetation cover, so we can make a mask for the image to get rid of this value or to eliminate these pixel values. For this purpose, of course, we have to go to the same place, which is raster calculator. And in this purpose, we're gonna use the conditional function right here, the first one, condition, and we have the NDVI for 2019. If it's bigger than 0, then place the NDVI itself. So we can mask this, or we can name this NDVI 2019 mask. So mask. So it's a process of masking the NDVI to, as you notice, we have this value, so we doesn't have the minus value anymore. So it started with the plus values only. If we off these values, if you notice that areas, they or it deleted these pixels which has the minus value. So we're gonna repeat this process for 2021 to, so we have condition 2021 bigger than 0, then 2021. So we're gonna name this with NDVI 2021 mask. So we can, depending on the classes which is represented in this table, and also take these minus values out of calculation from masking process. So we have NDVI, we calculated NDVI for these 2 years, and we make a mask for these 2 NDVI. Well, after calculating the NDVI, we are now about to calculating the LST, which is the land surface temperature. And in order to calculating the LST, we have some steps in order to obtain the LST, or land surface temperature. First of all, we have to calculate the TOA, or top of atmosphere spectral radiance. In this purpose, we have this formula, which is ml multiplied by q col add to al. ml and al are multiplicative risk scale factor and additive risk scale factor, and q col is the band 10 itself, which is used to calculating the LST. You know, for LST we use it band 4 and 5, and for LST we need band 10 if we have the Landsat 8, of course. So it's band 10 for Landsat 8. So we have, as I said, multiplicative for ML and additive for AL, and we have band 10 right here. So let's calculate the TOA, or top of atmosphere, for each of 2019 and 2021. So let's start. Of course, we need a raster calculator, and we have ML, which is this one, or multiplicative risk scale factor, which is represented or equal to this value. So we have this value already, and we have the additive value. We have band 10 too, so it's ready for calculation. So we have ML multiplied by band 10 for 2019 plus 0.1. So this will be the TOA for 2019. And of course, we have to do the same process in order to clip the output. So we'll choose the shapefile that we have in order to clip the output image. There we go. So we have TOA for 2019, and we have to repeat this process for 2020. So again, we have the ML value multiplied by band 10. This time we will choose the 2021, add 0.1 or plus 0.1. So we're gonna name it as TOA 2021. TOA sorry, so we forget to clip it, so we're gonna repeat it, and of course we can clip in another way, but this is the easiest way for clipping. So we're gonna repeat the process, multiplied by band 10 of 2021 plus 0.1 TOA 2021. There we go. So we have TOA for 2019 and 2021. So that was the first step for calculating the LSD. So in the second step, we're gonna convert the TOA to the brightness temperature, or BT. in some references they call it TB. It's okay. So BT or TB are the same. It's depending on the references that they mention it. So we have BT, brightness temperature, and we have this formula K2 divided by natural logarithm of K1 divided by L. So both of K1 and K2 are values that we can find it in the metadata file, just like the multiplicative and additive values that we can find it in the metadata file, which comes with the downloaded images. So K1 and K2 are constant that comes with the or inside the metadata file, and we have L, which is representing the TOA that we calculated recently, and we have this value, which is converting the converting the absolute value to the Celsius value. So this is just for conversion. So we have K2, K1, L, and this value. So now we have the this formula ready. Those value, as I told you, comes from the metadata file. So we will go to the ARC toolbox, raster calculator again, and we have this value divided by, so I'm gonna this one. So I'm gonna add a bracket right here and divided by logarithm of, or the natural logarithm of, add another bracket. I'm gonna copy this number and then divided by TOA for 2019, out of the bracket plus 1, and then double bracket, one for the logarithm and another for the first bracket, or the second bracket, sorry. So minus 273.15. So we're gonna name this BT 2019. So let me check it for the last time. We have the same values. Okay. So again, we're gonna use the our shapefile, and by the way, you can make all the processes, the entire process, and after that you can clip the image. It's the same way, for example, doing all the processes for calculating the LST and then clip the image. It's the same. So we have the BT right here. We have the BT brightness temperature for 2019, and we're gonna calculate again for 2021. This is divided by sorry, we make a mistake. So this is the first value and this is the second value divided by TOA of 2021 and plus 1 and minus 273.15. So we have a problem with brackets. This is 1 1. Yeah, we have an extra bracket which is right here. Now it's okay, so we're gonna name it like the previous BT for 2021. Yeah, so if you notice, we have the brightness temperature for the two years 2019 and 2020. If you notice, the temperature or the values in the right here in the BT or brightness temperature of 2019 and 2021, actually they are representing the temperature, and in some researches they are depending on this value as the final temperature. If you ask our question or if we ask ourselves a question, can we depend on these values as a temperature, as a real temperature? The answer is yes, we can, depending on them as a real temperature. But the rest procedures or the steps is just for correction the temperature to minimize the effect of vegetation on the temperature. So it's dependable. We can depend on this value or depend on the brightness temperature value as a temperature, as a real temperature. But as I said, we make another steps for calculating the LST just in order for make it more accurate. But if you notice, we have some unique value right here. It's minus 13, and it's abnormal value, because if we check it and those are the values that representing the minus, which are very little number of pixels, and it's kind of error, so we can make a mask in order to take or get rid of these values. So it's very okay, we can ignore these values. So the next step for calculating the LST is calculating the proportion of vegetation, or PV. So we need this formula in order to calculate it. We have square NDVI, which is the NDVI value or the NDVI image or layer, NDVI minimum, the minimum value of the NDVI for the same year, and we have maximum and minimum. So we go to the raster calculator, and we have a square, another bracket. In this point we have, we have NDVI itself and NDVI with mask. Now in this training course we gonna use NDVI 2019 with mask, but sometimes they are using just NDVI without masking. So we prefer to use it with mask, or after deleting of the non-vegetation areas. So we're gonna use NDVI for 2019, which has been masked, minus the minimum value, which is this value, divided by NDVI max, which is 0.63 minus the same minimum value, well, so we use it the maximum and the minimum values of the maximum or the minimum and the minimum value of 2019 after masking. But in some procedures that are just depending on the standard value, that is 0.2 and 0.5. This is for minimum and this is for maximum. So which one is more accurate, or which one is dependable, actually is depending on the many variables. And in this video or in this course, it's just a tutorial course, just learning course. So it's very okay for using this value as a standard value, and they are used or usable for or in many researches, and we can use these values as minimum and maximum value. And of course the minimum value may be lesser than 0.2, and the maximum value may be bigger than this, as we can notice in our image. But we can use this value, and we can use the values from the image itself. So both are used in the researches, and both are as I said, usable, and is depending on the kind of the research or kind of work. So we name this PV for 2019, and okay. So this is the PV, or proportional vegetation, for 2019, and we'll make it again for 2021. So we have a square NDVI mask for 2021 minus the minimum value, which we can find it in these image, or in the image itself, which is 0.00002 or 22. So 1 2 3 4, okay, divided by NDVI maximum for 2021, which is 0.61 minus 0.000022. So we name this PV 2021. So we have PV for these 2 years. Okay, we jump to the next step, which is calculating the emissivity, which usually have or has its or this symbol. It's a very simple formula, and which has 2 constants, 0.004 and 0.986, and we have PV for the same year. So we're gonna go to the ARC toolbox again, raster calculator, multiple by PV for 2019 plus 0.984, 36. So this is the emissivity. We can call it E or whatever symbol you want for 2019, and okay. Again for 2021, so we call this emissivity for 2021. There we go. So we have the emissivity for the both of the years, and the final step is calculating the land surface temperature itself, which includes the BT or brightness temperature that we calculated before, and we have these values, they are constant, and we have the logarithm of the emissivity. So let's start. So we have bracket BT for 2019 divided by 1 plus 0.00115 multiplied by BT again for the same year and then divided by 1.4388 multiple by the natural logarithm of emissivity for the same year. Well, so we have BT divided by 1 plus so we forget a bracket right here, 0.001, so we need a bracket right here, 1 plus this value multiplied by BT divided by this, and we need another bracket right here. So it's ready to go. Let's name it LST for 2019. So here's the formula. There we go. Again, we need this process for calculating the so we need BT for 2021 divided by a bracket 1 plus bracket 0.00115 multiplied by BT divided by 1.4388 multiplied by the natural logarithm of emissivity for the same year. So we're gonna call this LST 2021. So now we finish calculating the LST for 2019 and for 2028, as you notice. So let me change the color to so if you notice the variation between the brightness temperature and between the LSD itself is very sparse or very low. It's about maybe part of 1 Celsius degree, lesser than 1 Celsius degree, and these differences in this value we can consider them as a correction, because as I said before, we can, depending on the BT, and they are doing it in many researches, they are depending on the BT as a land surface temperature itself, but we calculate the PV and emissivity in order to calculate or to perform the final LSD, just for correction the image from any kind of errors. So those are the temperature, and as you can notice, the green values representing the lower temperature, and the red and orange one are representing the higher temperature. So this is or that was the procedure of how to calculate the LSD, depending on the some steps and some formulas using the Landsat 8 images. Now we will jump to the next index in this training course, which is the Vegetation Condition Index, or VCI. Of course, in order to calculate these indexes, we need NDVI, or the NDVI for a certain year, and maximum and minimum value for the NDVI. So we need ARC toolbox, raster calculator. So we have NDVI image, of course, that one which we make a mask for it, NDVI 2019 mask minus minimum value of NDVI. Right here we have or there is a note that should take into consideration, which is if you have only 1 year. For example, you'd like to know how the vegetation look like in the in a certain year, without using time series or different years. So let's guess that we have only 2019, and we need to apply all of these indices only for 1 year in order to know the vegetation condition in that year only. In that case, we have NDVI for 2019. So in this case, we will use this minimum value, this minimum, and this maximum in that formula. Okay, so in that case, if you have only 1 year, we will put this value 22, I think 23, multiple or divided by maximum value of NDVI. Which one? The 2019, because we have only 2019. So 0.63 minus 0.00023 multiple by 100. Okay, so we will use this value. We will use these values for this image, which is 2019, if we have only 1 year. Okay, but because we have 2 years, or we have time series, so in that case we have to calculate the minimum and the maximum value for both of them. So in that case, we will use, of course, ARC toolbox, and we will use spatial analyze tool, local, and then cell statistics. We have or we should put the NDVI 2019, NDVI 2021, and we will tell the software, or tell this function, that you have to calculate the minimum value for these two images that we selected. So we will name it minimum of 2 or minimum NDVI, and OK. So now we will it will calculate the minimum value depending on these two images, because we have 2 years, 2 different years, and of course if you have 10, 20, as much as we have, we should calculate in the same way. So this is the minimum value layer or image depending on the these 2 years. So we will again repeat this process in order to calculate the maximum value according to these years. So we will choose maximum instead of minimum. We have right here, if you notice, we have maximum. So it will calculate the maximum value depending on these 2 years. There we go. So we have we should rename it max NDVI. So we have minimum NDVI and maximum NDVI. So now we are it's ready to calculate the VCI. So we will choose this process if we have more than 1 year. 2 or more years, we should calculate the minimum and maximum value of NDVI just like we did before. And if we have 1 years, we will use the NDVI minimum and maximum value. So we go to the raster calculator again. We have NDVI for 2019, the mask one, minus the minimum value. We will choose this minimum that we calculated right now, minimum. Close the bracket, divided by maximum minus minimum. Close the bracket, multiply by 100. So we choose maximum and minimum as a layer instead of numbers, because we have several or more than 1 years. So we will name this VCI for 2019, because we use NDVI 2019. Okay. Now we have VCI that its value from 0 to 100, and we will repeat this process in order to obtain the VCI for 2021. So we have NDVI for 2021 minus minimum divided by maximum minus minimum. So we will use the same layer, maximum or minimum and minimum, for as much as year that we have. We only change the layer that we need to calculate the VCI for it. So multiply it by 100, and we're gonna name it again VCI for 2021, And okay. So it's finished. Now we have VCI for 2019, VCI for 2021. Um, well, so as you notice, there is huge differences between these 2 years that shows the vegetation condition in the study area. Each one shows the different pattern, which are significantly different from the others. Well, that was the procedure to how to calculate the VCI or vegetation condition index. The next index in this training course is the temperature condition index, or TCI. Of course, after we calculate the vegetation condition index, or VCI, now we will calculate the TCI. In TCI, of course, we need the LST for a certain year, and maximum and minimum value of the LST. And as we mentioned before, in the VCI, if we have a certain year, we will use the minimum and the maximum value for that LST. For example, if we have the 2019 LST, we have only this year, so we're gonna use these as minimum value and these as maximum value. But because we have 2 years, so we have to calculate the minimum and the maximum just like the NDVI. So in that purpose, we will go to the cell statistics and we will choose the LST for 2019, for 2021, and we will choose the minimum, and we will call this min of LST. And okay. So this is the minimum layer of the LST depending on these 2 years. Now we will calculate the maximum layer depending on the LST of 2019 and 2021, and you will choose maximum, and we're gonna call this max of LST, and okay. And as you notice, we have 2 different layers. Each one represent the One of them represent the maximum and the second one represent the minimum value. So it's ready for calculate the TCI. Depending on this formula, we have LST max minus LST. So we have a bracket LST max minus LST for 2019 divided by a bracket maximum minus minimum and multiple by 100, and we're gonna call this TCI for 2019. Okay. So let me off these values or these layers, and this is the TCI for 2019. We will calculate the TCI for 2021. We have a bracket LST max minus LST of 2021 divided by maximum of LST minus minimum of LST layer. LST, okay, multiple by 100 TCI for 2021. Okay. So this is the TCI, temperature condition index, for these 2 years. And if you notice, there are huge differences between these 2 years. So now TCI is ready for use. The final index is calculating of vegetation health index, or VHI, and it's very simple depending on the VCI and TCI, and those values are constant. So we have 0.5 multiplied by VCI. We will use raster calculator. 0.5 multiplied by VCI of 2019 plus 0.5 multiplied by TCI. VCI for 2019, TCI for 2019, and we will name it VHI, Vegetation Health Index, VHI 2019, because we use it 2019 for both VCI and TCI. And I will repeat the process for 2018. 0.5 multiplied by VCI of 2021 plus 0.5 multiplied by TCI of 2021. VHI 2020. So those are the entire process or the procedure of calculating the VHI depending on these formulas.